Hello and welcome back. In this video, we're going to be talking about calculating the gradient, okay? This time a slightly different way from a table of values. Table of values we know is a very, very useful tool for graphing linear relationships, okay? However, we're going to start heading the opposite way and looking at a table of values to go and find the original rule for the linear relationship that we're after. We know when we're looking at a table of value, each of these essentially refers to a set of ordered pairs, otherwise known as coordinates. For example, this first one is xy. We relate that to the point 0, 5. Okay, this one down the end here is the point 20, 35, because we have an x and we have a y value. Okay, so we want to make sure that we understand how we're able to use those. Just so happens, okay, that we're able to go and use these to calculate the gradient of the line. And in a future video, we'll talk about how to go and calculate the entire equation of a line based off of a table of values. Okay, first thing, as a little bit of a recap, remember our gradient refers to the steepness or slope of a line and is calculated by our rise divided by our run. Okay, now this basically means our change, okay, in y over our change in x. Now, I really want you guys to understand what I mean when I say that. Okay, so I'm going to say it lots of times. We are talking about subtracting, okay, i.e. the difference, okay, between two y values and the difference between two x values. Now, as I've said to you beforehand, okay, we can calculate the gradient between 2 points if we wanted to. As we know, each of these things here are going to be 2 points. All we have to do is we just have to look at the change in values between the x values and the change in values between the y values. So for example, if I look at the change between these 2 points here for my y values, we would be looking at the run. Okay, so for example, the rise, my apologies. Okay, let me fix that up. So for example, if I want to calculate my rise in between those 2 points, it would be the difference between them. It would be 11 minus 5. So the rise from 11 to 5, I go up 6 when I'm traveling along this line. Similarly, okay, if I go and look at the top here, this would be the change in my x values, i.e. my run. So if I want to calculate the run, okay, I just take in the same order as what I've done. So notice I've done 11 minus 5 here. So in this particular order, I'll do 4 minus 0 up here. Okay, the larger minus the smaller. 4 minus 0 will give me a run of 4. Okay, the order that you do this in is really important because it'll help you calculate the gradient accurately. Okay, so now I've done my rise and my run. My rise was 6. My run was 4. Okay, I end up getting 6 over 4, which we know is a gradient of 3 over 2. Now, I hear you ask, does it matter which 2 points we pick? The short answer to that is no. So I'm going to show you by calculating between 2 points. Doesn't matter which 2 points you pick, you'll always get the same answer. It just means you might need some more simplification. So I've just copied and pasted the table of values down here. I'm going to show you no matter which 2 points we pick, we'll always get the same answer for our linear relationship for the gradient. Okay, so let's do the run first. We'll do that in red. Let's pick these 2 points here. Okay, to calculate the run, that's going to be the difference in those 2 points. Okay, so it's equal to our bigger point. Okay, 20 minus 4, which is equal to 16. If we go and calculate the the rise, again from the same point, 35 down to 11. Okay, we end up with 35 minus 11, okay, which will give us 24. Okay, now when we go through and we start calculating our gradient, all right, this particular time, our rise, 24, over our run, 16. Once we put it into our calculator, okay, we'll see that it'll simplify down to still be the same 3 over 2. So it doesn't matter which 2 points you go and pick, okay, they'll always give you the same answer. The main thing that you have to be very careful of is if I do 35 subtract that way to the 11, okay, I also have to do 20 subtract that way to the 4, okay, right? Just making sure that you keep your order in the correct order. Now, you might ask the question, can I go the opposite direction? 4 minus 20 and then 11 minus 35. The answer is yes, you'll get the exact same answer, but these two values will end up being negative, which just means you'll have to cancel a negative over in your final answer here. It adds a little bit of extra work for you in the grand scheme of things, okay? So is it possible? Absolutely. Okay? All right. So I'm going to move down to another question for you to have a little bit of a practice with. Okay. Feel free to pause the video here before we start. Okay. And we'll go from there. Alrighty. So first things first, you would probably notice if I'm going to calculate the gradient from this table of values. All right. It's always handy to write run for your X, rise for your Y, just to go and label everything out. Okay. And what I'd suggest to you to do is try and pick some easy points. I'm going to show you again, no matter which points you pick, it'll work. Okay. So for example, let me unzoom from there. Okay, calculating my run, I'm going to do 3 minus 1. Okay, so my run is equal to 3 minus 1, which will give me 2. Okay, then for my rise, which is down here for my Y values, okay, I'm going to have rise is equal to, in the same order, 3 minus 7, which is equal to, being very careful here, negative 4. Okay, putting that in, okay, all together, we now have our gradient is equal to our rise, minus 4, over our run, which when we simplify down will give us the answer of negative 2. So this will be a line that's sloping to the left, okay, looking something like this. And that becomes a little bit apparent, okay, when you look at this first point, we would be up at 1, 7. Then at 3, we've come down in our Y values. Then at 6, we've come down in our Y values, again, down to negative 3. Then at 8, down here to negative 7. That's what's happening as we go along, okay? We're decreasing in Y values as we go along our X axis, okay? Now, the things that I want you to take away from this, okay? First and foremost, be really careful for your negatives, okay? This will often trip you up if you're not watching, okay? Second, make sure that when you subtract one way, okay, you keep it in the same order when you go and calculate the rise or the run, whichever one you're doing second. Okay, I hope that's been helpful. We'll use this to go a little bit further later on. Thank you very much.